Hello again, I'm still Emily, shocker, and now we're going to be doing a telescoping summation, which is a lot more interesting than previously. So we actually don't even need this formula chart over here for this. What telescoping means is that a lot of the middle terms of the summation is going to cancel out. And the way that I know this before I even started the problem is that first off, there's multiple terms connected by a minus sign, and those terms seem really similar. Even if I don't really remember how exponents work, one has a j in it, one has a j plus 1. That's a good sign about telescoping. Remember, j is this index here before it was k in the previous video. It can be whatever variable you want. People who are familiar with algebra and exponents might realize you could simplify this to one term, but we're not going to do that here. We're going to get practice with the telescoping. And the way I start a telescoping problem is to write out a bunch of terms at the beginning and write out a bunch of terms at the end and see what's left over. So for j equals 0, I like to write which index I'm using so I kind of keep track. So we get 2 to the 0 plus 1 minus 2 to the 0. For j equals 1, we get 2 to the squared minus 2 to the 1. And for j equals 3, we get 2, oh, I skipped one. J equals 2. That's the next term. We get 2 cubed minus 2 squared. Okay, this feels like enough terms this direction. And let's see if we have things starting to cancel out. Well, we have, I'll use a different color. We have 2 to the 1 and a negative 2 to the 1. So those go away. We also have 2 squared and negative 2 squared. And now I'm going to take a guess. If we wrote out j equals 3, we'd get some negative 2 cubed here, and so these would cancel out. Okay, cool. So we got to keep track of what didn't cancel out, though. It's really easy to lose it in all the slashes. This term we haven't gotten rid of. And now let's go see what's happening at the end of the summation when j starts to approach n. And I'm going to start with j equals n minus 1. One term before we end. And so now we get 2 to the n minus 1 plus 1, also known as 2 to the n. And then we subtract 2 to the n minus 1. And then our last term, j equals n. So we get 2 to the n plus 1 minus 2 to the n. Okay, what's canceling here? The 2 to the n and the negative 2 to the n cancel. This term isn't going to cancel with anything because the negative term would be over here and we don't have it. And now we got to figure out if this term cancels, and sometimes it's hard to remember or convince myself that I'm sure of it, so I often back up another term and write the j equals n minus 2 term. And so we get 2 to the n minus 2 plus 1, which gives n minus 1. We subtract 2 to the n minus 2. We add these, and then look, these cancel. This will cancel with something over here. And so we're only left with the two terms boxed in orange. 2 to the n plus 1 minus 2 to the 0. Or we could write that. 2 to the 0 is just 1. And that's it. That's our answer. We're done. No formulas necessary. Just a lot of crossing out.